Great job so far! I'm Adrian and I will now tell you about data preparation. Data preparation happens after collecting and storing the data. Data rarely comes in ready for analysis. Real-life data is messy and dirty. It needs to be cleaned. Skipping this step may lead to errors down the way, incorrect results, or throw off your algorithms. You wouldn't use vegetables without cleaning, peeling, and dicing them, as your soup would taste weird, and no one would eat it. Well, if you don't clean, peel, and dice your data, your results will look weird, and no one will use them. Let's take a simple but dirty dataset and clean it together. Maybe you can already notice a few things. One fundamental aspect of cleaning data is tidiness. Tidy data is a way of presenting a matrix of data with observations on rows and variables as columns. This is not the case here. Our observations, people, are in columns and their features, like age or country, are on rows. Let's take care of that. It's easy to do that programmatically with Python or R. They also help with the other cases you're about to see. The data looks much clearer this way. In general, you want to remove duplicates. Python and R make them easy to identify. Here we can see that Liz appears twice. So let's remove the duplicate. But what if there's another person called Liz? Then you want to uniquely identify each observation. It can be a combination of features, name plus last name plus year of birth, for example, but the safest way is to assign a unique ID. Sarah's ID is now 0, Liz 1, and Adrian's 2. Something fishy is going on in the size column. Liz simply can't be that tall, or Adrian and Sarah that small, depending where you're from. Liz is in the US. She inputted her size in feet. Sarah and Adrian are based in Europe. They use the metric system. All variables should use the same standard. Programmatically, you can filter values above 2.5 meters and apply a division by 3.281 to get the metric value. Here we go. Similarly, countries should follow the same format. The United States and France are abbreviated, but Belgium is written in full. Let's fix that. Looking better already. Another common issue relates to data types. The tools you use might be able to infer data types for each column, but you'd better make sure they are correct. Here, the age column is encoded as text. If you try to get the mean, you'll get an error because the average of two words doesn't make sense. You should change the type of this feature to numbers. Ages are now numbers. You can see the quotes have disappeared. Last but not least, missing values. They are common and occur for various reasons. The agent doing the entry was distracted, the person surveyed did not understand the question, or it's on purpose, for example, an event that has not happened yet. There are several ways to deal with missing values. You can substitute the exact value if you have access to the source. Or you can take an aggregate value, like the mean, the median, or the maximum, depending on the situation. You can also drop the observation altogether, but each observation you remove means less training data for your model. Or you can keep it as is and ignore it if your algorithm allows it. Here, we take the mean, 27.5, and round it up to get 28, which happens to be the correct value. Let's check your understanding.